Hello and welcome students. This is a lecture on linear programming problems and this lecture is lecture number 3. Lecture number 3 on linear programming problems. So in the previous two lectures, we have done a lot about linear inequations and then we also solved those linear inequations graphically. In the previous two lectures, you have studied it. In last lecture, that is lecture number 2, we had seen two linear inequations solved graphically simultaneously. So we started with solving one linear inequation. We started with solving one single linear inequation graphically, that is, suppose you are given one single linear inequation like this and you have to solve it. So that is on the xy plane, you wish to find out which set of points satisfy this linear inequation. Then after that, we went for two linear inequation in last lecture you saw. So when you have two linear inequations, what you will have to do is you will have to plot the solution set of this linear inequation, then also the solution set of this linear inequation, after which you shall find out the common solution set. That is, you shall find out the set of points in the xy plane which simultaneously satisfy this linear inequation as well as this linear inequation. So this we had done in the last lecture. Now in today's lecture, we are extending that to few more linear inequations. Like we have already done for 1 and 2 linear inequations. Now this time you have the third linear inequation. So we have 3 linear inequations. Now you would be thinking that why is 3? We have actually 4 and 5. That is correct. You can say that we have 5 linear inequations. But when you see x greater than or equal to 0, or you see y greater than or equal to 0, then we normally call them as non-negative linear inequalities. They are given special name. They are also called as non-negative constraints. Yes, the word is constraints. Students, inequalities, remember, inequalities are also written as constraints. So you can say that this is a constraint, this is also a constraint, this is a constraint. These two are also constraints. Why they are constraints? Because here you are being put to a condition that x cannot be negative. You are put to a condition that x cannot be negative. X has to be 0 or greater. X has to be 0 or greater. You can check. So when x has to be 0, x can be 0 or x should be greater than 0. This is known as non-negative constraint. This is also y should be 0 or greater than 0. So these two are non-negative constraints. So in total, we have 5 linear inequalities or 5 constraints, of which of these 5 linear constraints, these two are non-negative constraints. And what I have to do, I have to go for feasible solution. I have to find the feasible solution. Now this is a new word for you, feasible solution. Remember students, feasible solution is nothing but common solution. common solution set. Okay, so how do we define feasible solution? A solution which satisfies all the constraints simultaneously is called a feasible solution. So I can define the feasible solution. I can define feasible solution for you as follows. So here I'm defining the feasible solution, and I write a solution which satisfies a solution which satisfies all the constraints, all the constraints simultaneously. A solution which satisfies all the constraints simultaneously is known as a feasible solution set, or feasible solution. Feasible solution. So this is the definition for feasible solution. So what I have to do here, students, I have to find the feasible solution of these linear inequalities. Now what I will do is I shall prepare a table here, and in that table you will understand that how do I solve it, because I have here more than two linear inequalities, so I need to be doing it properly. So see, first of all, I go for a table and see how is that table prepared and what do we actually have in that table. So here we have the serial number. Then here we have inequations. See, the first column is inequation. Inequation. Then the second column is equation. That is, you know that for every inequation, we will have to write an equation, because with the help of that equation, we will plot the straight line. We will plot the straight line. And in order to plot the straight line, you will have to find the intercepts of the line on the coordinate axis. So here I will write intercepts. The next column is intercepts. Now you know you have x-intercept and y-intercept. Then the next is solution set. Solution set. Okay. Or you may also write here region with respect to origin. That I will tell you. The region with respect to origin. So Here now I begin with I have total 1, 2, 3, 4, 5. So let us begin with the first one. See here. I have the first one. This is very simple, students. Okay, you just need the help in one of the question. Once you get it, then the rest you can solve. You need to understand just one. This is very, very, very simple. See, the first one is, I write here the inequation x plus 4y lesser than or equal to 24. That is x plus 4y. See, x plus 4y equal to 24. For this inequation, this is the equation. Okay. Now this equation represents a straight line. It represents a straight line. So now what I do, I'll have to go for the x and y intercept of this straight line. Now for x intercept, you put y0. So when you put y0, you get x as 24. Okay, so 24 is x intercept. And what is y intercept? For y intercept, you put x0. So when you put x0, you get y as 6. Okay, so the point on x-axis, the point on x-axis and y-axis. So the point on x-axis will be we can have one more column here. Point of intersection with x-axis and with y-axis. We can have one column like this. So if the x-intercept you saw point of intersection with x-axis. Now you saw that this line has x-intercept 24. So 24, 0 is the point of intersection with x-axis. And the y-intercept is 6. So 0, 6 is the y-intercept. Okay, so this is for the first line. Now, so far as the solution, the region with respect to origin is concerned, the region with respect to origin, that is the solution set. Which side of the line you are going to plot the line? Now, which side of the line is the solution set? Whether it is the origin side or it is non-origin side, that we will do all together. So this was the first one. Now let's go for the second one. I will write this line. So it is, second one is, you have 3x plus y lesser than or equal to 21. That is 3x plus y equal to 21. Now, in order to get the x-intercept, you put y0. And when you put y0, you get x as 7. And when you put x0, you get y as 21. So you get 7, 0. See, the x-intercept is 7. Okay, so the number on the x-axis where line meets the x-axis is 7. So the point of intersection will be 7, 7, 0. And here it is 0, 21. Okay, the line meets the y-axis at 0, 21. Then I have the third one. The third is x plus y lesser than, the third is x plus y lesser than or equal to 9. Now for this you have x plus y equal to 9. So the point of intersection with the x-axis will be 9, You put y 0, you get the x-intercept 9. You put x 0, you get y as 9. So the point of intersection on the coordinate axis will be 9 0 and 0 9, 9 0 and 0 9. Okay, then after that we have these non-negative constants. Students, in fact, there is no requirement for these two non-negative constants. You have no requirement because non-negative constants, you understand that they are only to make us understand that everything will come in the first quadrant. That is what is the meaning of this. See, this is y-axis, this is y-axis, this is x-axis. Here you have origin. Now, once you say that x is greater than or equal to 0, so you understand that everything is going to be x greater than or equal to 0. So you understand that everything is going to be, it is all going to be on the right side of y-axis. It is all going to be on the right side of y-axis. This is the way it is going to be. See, this region, you have x greater than or equal to 0. Try to understand this region is x greater than or equal to 0. Then y greater than or equal to 0, you all understand that it is this region, which is y greater than or equal to 0. So, but now you have both of these. So when you have both of these, you need to have this as well as this, both x greater than equal to 0 and y greater than equal to 0. So you must understand that x and y both will be greater than 0 in this region only. See, this is the region where x and y both will be greater than 0. That is in the first quadrant. Everything will come in first quadrant. See, in the second quadrant, y is greater than 0, but x is not greater than 0. So what is happening? In the second quadrant, this is being satisfied. In the second quadrant, this is satisfied. This is not satisfied. So you can't go in second quadrant because you have to go somewhere. You have to select those set of points which are satisfying both the constants simultaneously. In the fourth quadrant, you have x greater than 0, but this is not satisfied, so you can't go in fourth quadrant. So where should you be going? You should be going only in the first quadrant. So no need to go for, see, we are not taking x greater than equal to 0, y greater than equal to 0 in this column because that is not required. Okay, this is x greater than equal to 0 is y-axis and to the right of it, and y greater than equal to 0 is x-axis and above it. So this is what we have done. Now what we will do is we need to be plotting these lines. See, now I will plot these lines on the graph paper and I will write the solution set. So for that, we'll have to go to the next page. You can copy this much. So in order to plot these lines, see, the first thing that we will do is we will have to plot these lines on the XY plane. Okay, so for that, I draw the coordinate axis. And see here, I have drawn the coordinate axis, the y-axis, the x-axis, and then I have one thing you will specifically find here that I have made the first quadrant too big, but the second, third, and fourth quadrant are not prominent. The reason is that in the beginning only, I saw that there are non-negative constraints. And whenever you have such constraints, it means the whole thing will appear in the first quadrant. So I have drawn y-axis, x-axis. Then look at the numbers which I take on y-axis and x-axis. Okay, I have taken 1 centimeter. Students, you will, this is, say this is 1 centimeter in the scale. This is 1 centimeter in the scale. So I have taken 1 centimeter as 3 units. Now, why did I do that? Because I saw here that on x-axis, I have to go up to the number 24. I saw that on x-axis, I have to go up to 24. And On y-axis, I saw that I have to go up to 24 on x-axis. This is maximum number that I would need. And for y-axis, I need to go up to 21. So I did so that I took 1 centimeter as 3 units. So within 8 centimeter, I will go up to 24. Now let's go for the, so here on y-axis, I could accommodate 21, and on x-axis, I could get 24. Now I go for the point. So here, see the first line, I now go for the first line, and the first line is x plus 4y equals to 24. Now this line has point of intersection with the x-axis as 24, 0, and with y-axis as 0, 6. So here I have one point, and the point is, I have a point here. This is 24, 0. See, this is one point I have. This point is 24, 0. And the other point that I have is 0, 6. These are the 2 points I have, 24, 0 and 0, 6. Now I will draw the line. I will draw the line now. So here I draw the line. The line has to pass through these 2 points. And see, this is the line which is passing through 24, 0. It is passing through 24, 0. This point is 24, 0. And this is 0, 6. And what is the line? The line is x plus 4y. I write the equation of the line x plus 4y equal to 24. Students, immediately after this, I will go for its solution set. That is, now see, you know that this line divides the xy plane into 3 disjoint sets. It divides the xy plane into 3 disjoint sets. One is the line itself, and the other 2 are the 2 halves, one above the line and the other below the line. Now, the inequation that we have in the question, that inequation, which region does it indicate? Now, this inequation that we have, this inequation represents the origin side of the line or the non-origin side of the line. Okay. See, students, I have already plotted the line. So having plotted the line, the points which are on the line, I have included, because see, it was equal to and lesser than. Try to understand. The inequation was x plus 4y equal to and lesser than 24. So you have taken care of equal to part. Now you have to take care of lesser than 24 part. So for lesser than 24, see what I will do here. I will now, see, I write here, put x equals to 0 and y equals to 0 in x plus 4y lesser than or equal to 24. Okay, that is, I'm checking with the help of origin. Okay, I'm putting the coordinates of origin in the equation. So I get here 0, 0 plus 4 into 0, that is 0 plus 0 lesser than or equal to 24. That is 0 lesser than or equal to 24, which is true. Which is true. What does that mean? It means that the origin, the coordinates of the origin satisfy this inequation. It means the solution set represented by this inequation contains the origin. It contains the origin. Okay. So the solution set will be on the origin side of this line. The solution set will be on the origin side. So in short, what we can say is the solution will be this side of the line, because see, here is the origin. You have the origin here. So 0, 0 you substituted. So this side of the line is the solution set. Okay. But remember, students, there are few things which we have to add up to before actually going for the solution set. And see, what are those things? I'll tell you that. First of all, remember that you do not have just one linear inequation. So you will not go for the solution set immediately. So instead, what I have understood, see, I will put some crosses here, very light cross I will put. Now see, what does these cross, what does these cross represent? These crosses I'm putting above the line. Now, this I'm doing in order to make me understand that the solution set of this line is on the origin side. The solution set of this line is on the origin side. It is not this side. It is not this side. That is why I'm putting cross this side. Okay. And these crosses I will remove. Now, see, why haven't I put a cross here? This is also above. See, I'm not required to go there because it is in second quadrant anyways. I am not required to go there because it is in second quadrant. Okay. And here also I'm not required to go because this is in fourth quadrant. You know, everything that we are doing, it is all in the first quadrant. So this is done. Now we will move to the next. Now I go for the second one. I draw the second line corresponding to the inequation, that is 3x plus y equals to 21. Now here I have 7, 0 and 0, 21. So see, 7, 0, you have 6 and then after that you have 9. So where would be 7? So definitely 7, 8 and 9. So somewhere here you have 7. This is number 7. Okay. So you have 1 point, you have point of intersection of the line at this, and 21, 0 is this. Okay. So let's go for these two. So this is 7 and this is 21. I draw the line. And the line is this is 7, 0. This is 7, 0, and here you have 0, 21. Then the equation I will write, the equation is 3x plus y. The equation is 3x plus y equal to 21. And then I have to go for the solution side. So here I will write origin side. See, this one we got was origin side. This one that we had got, it was the origin side. Let us work for this. Here, what do we get? So this is, I will put origin coordinates in this. And as a matter of fact, remember students, you will again get origin side. Yes, you will again get origin side. I tell you why. Remember, whenever you have any inequation which is in the form ax plus by lesser than or equal to a positive number, remember this. Okay. If you have an inequation which is ax plus by lesser than or equal to a positive number, this is a positive number, then the solution set is always on the origin side. Okay. See, this A can be negative, B can be negative, irrespective of that. If you have on the right hand side a positive, it will always come the origin side. Okay, so here you can check. I will write, put x equals to 0 and y equals to 0 in 3x plus y lesser than or equal to 21. Now see, when you put x0, y0, you get 0 plus 0, which is 0 lesser than 21, which is true. So if it is true, what does it mean? the coordinates of the origin satisfied this inequation. It means the solution set represented by the inequation contains the origin. So once again, you will write here origin side is the solution set, the origin side. Got that? Now, origin side, it means here what you have drawn. Again, what you will do, you will put some crosses here. You put a cross. See why you put the cross this side? Because you have understood that the solution set is this side. You have understood the solution set is this side, but you will not do it. What you will do instead is you will put the cross. So here you will put a cross, you put a cross, a cross, and definitely you put a cross here. Okay, because this is not the solution. Listen, students, listen to this very carefully. If you consider the red line, then this is to be taken in the solution set, this portion. Why? Because this portion which you have, this portion is the origin side with respect to the red line, but I still put the crosses there. Why did I put the cross there? Because that belongs to the non-origin side of the orange line. So I put the cross there. Okay. Now what I will do next, see, this is done. I go for the next one, and the next one is x plus y lesser than or equal to 9. As I told you, the line to be drawn first. For this first, I'll draw the line x plus y equal to 9, 9, 0. And so here you have 9. See, you have the point here, 9, 0 and 0, 9. 9, 0 and 0, 9. You have the first, you'll have to plot the line. So I go for the line first. I go for the line first. So here is the line. The coordinates are 0, 9, 9, 0, and 9, 0. Then I'll write the equation of the line. The line is x plus y equal to 9. And the solution set of this will be once again the origin side. Yes, it is going to be once again the origin side. You can check if you're writing, put x equals to 0 and y equals to 0 in x plus y lesser than or equal to 9. You'll get 0 plus 0 lesser than, that is 0 lesser than or equal to 9. So definitely it is the origin side. What side it is? It is the origin side of the line. So here you have the line and the origin side. So see, you will put the crosses. So here you put the cross here. See, students, this is not there. Okay, this portion is not there. Why it is not there? Because it is non-origin side of red line. Okay, now this is not there. See, this portion is also not there. You know why this is not there? Because it is the non-origin side of the white line. We have to see the origin side of all these lines. This is not there. This is not there. So ultimately, what is the common feasible solution set? See, the common and the feasible solution set that you will see here is this. It is this. You can check. It is this. See, I cannot go beyond try to understand, students. I cannot go beyond y-axis and x-axis. I will have to remain in the first quadrant only. I will have to remain in the first quadrant only and this is the common solution set. Why I need to remain always in first quadrant? Because we also have to take care of two non-negative constraints. What were they? What were they? They were x greater than 0. See, if I extend the line here, it is wrong. Why? Because now I'm going to get y lesser than 0. These points are not there. I have to restrict myself only up to this. If I go ahead like this, it is not correct. Why? Because now I'm going to get x negative. X has to be positive. I'm going to the second quadrant, so I have to remain here. So you can understand, student, that this is the shaded portion that you are getting. The shaded portion that you are getting, it is the common solution set or feasible solution set or the feasible solution set. So here I will name it. See, I can write it as, see, I can write this point. Okay, before that, those all crossings which I had done, I will remove them all. I'll remove these all. Okay, it is like you also have to rub it later. You will rub them off, erase them off. So this is the final solution set. You can now write, I will name them. So this is, I write this as A, B, this point is C, then this is O, and here I write D. Okay, so A, B, C, O, D. And remember, students, this is a convex set. It's a convex set. I've already taught you what a convex set is. So I write the shaded region A, B, C, O, D is the feasible solution set. It's the feasible solution set. You can write here, since it is a feasible solution set, you can write S in this. Okay. This completes the problem.